Okay, one very important point about sets. There is a difference between equal and equivalent sets. Okay. Now, how? Equal sets, essentially A and B, if A and B are two sets, they are said to be equal when all elements, or for all x belonging to A, x belongs to B as well, and as well as for all x belonging to B, x belongs to A. So all elements in A belongs to B also, and all elements in B belongs to A also. But what do we mean by equivalent sets? Equivalent sets are perhaps when you have two finite sets, A and B are finite sets, okay, then they are equivalent if the number of elements in both are equal. So in case you have A is 1, 2, 3, 4 and B is A, B, C, D. Now both has how many elements? And A equals to 4 and B equals to 4. But does that mean that, whatever is there in A is there in B and in B is there in A? No. So, equivalent sets would just be when the number of elements in each are same. Now, just note another thing. What you should note is that whenever A equals to B, then number of elements in each would of course be same. Number of elements would in both will be same. Thus, equal sets are always equivalent. So, equal sets are always equivalent, but equivalent sets need not be equal, as we have already seen. Okay. So, this was the point that I wanted to make out here. Next, what I want to talk about are disjoint sets. Now, what do we mean by disjoint sets? Disjoint sets. Disjoint set essentially, disjoint set, two sets are known as, or are said to be disjoint in case they have no element in common. If they have no element in common. Okay. So, as you see in these two, okay, just take the example of the A and B given above out here. These two are disjoint sets. So, A and B are disjoint out here. Okay. They do not have anything in common. Okay. Next, let me just tell you what a subset is. Now, what is a subset? A subset essentially, if you have, say, two sets, this is A and this smaller set is B. Now, B actually is a subset of A because it is completely contained in A. That is, B is contained in A. This is containment. B is completely contained in A. What exactly will this mean? This actually means that, all elements of B should be there in A. Okay, so that means that A for all x belonging to B, x belongs to A as well. Okay, so that would mean that B is completely contained. When it is completely contained, we can write it as a completely contained symbol. Okay, because B in this case is not equal to A. The moment B and A are actually overlapping or are equal, then they are equal like this, and in the subset it is in the subset form there is this equal sign also, because the set can either be completely contained or it might also be equal to the other set. So this is what we mean by a subset. Now subset, for that example, say if you have your two sets are 1, 2, 3, 4 and the other set is 1, 2. So this set is completely contained in this set, right? So this set is completely contained in this set. What is a superset? Now when we are talking about subset, let's also look at what a superset is. A superset would essentially be, if A is a subset of B, okay, if, let me use green color here, if A is a subset of B, okay, if A is a subset of B, then which is the bigger one? Which is the bigger one? The bigger one is B, okay, right? Because A is a subset of B, then B is the bigger set. So B is the superset. B is the superset out of the both, and you can denote it as like this. Just opposite to subset. The symbol is just opposite to the subset. Okay. So that's what we mean by disjoint sets, subsets, supersets.